Hello friends, welcome to Learner's Planet. Friends, this is our fourth session for area and volume, or I can say about mensuration. In the previous session, we have discussed the basic terminologies related to various 2D and 3D shapes. We also did some problems based on trapezium and rectangle. In this session, we'll be taking more such problems. So let's begin the session, and I would suggest you do revise the previous sessions before coming to this session, because before solving the problem and while solving the problem, you should be clear about all the formulae related to 2D and 3D shapes. Okay, so let's begin the session. Let's take the problem. A man bought a rectangular plot of 144-meter length and 64-meter width. In exchange for this field, he wanted to buy a square field of the same area. Then the side of the square field would be. Now friends, what is the area of a rectangle? That is length into width. And what is the area of a square? That is side square. That means in the case of a square, both the sides are, that means all the four sides are same. So the person is wishing to have a same area in square plot, square size I can say. So there is no paperwork required at all in this question. This is the area, that is 144 into 64 is the area of the rectangular plot, and the same will be the area of, that means whatever the product is coming, that would be the area of a square. Now if we wish to find out the side of the square, that means we have to find out the square root of 144 into 64. So we can individually find out their square root. So square root of 144 will be 12 and square root of 64 will be 8. So 12 into 8, that is 96, will be the size of the square. So no paperwork is required at all. Okay, then also I just elaborate it over here. 144 into 64, that is area of rectangle, and the same is area of square. Or I can say it is side square. So side will be square root of 144 into 64, that is 12 into 8, 96. Okay, after some practice you don't have to write, or you will not be requiring all these things to write. Okay, I hope you are clear. Now further, once again let's try this problem mentally. The length of a diagonal of a square whose area is 16900. That means side square is 16900. That means side will be what? It's the square root of this particular number. Okay. Now what is the square root of 16900? 169 into 100. This number is, so square root of, this is side square. So side will be 13 into 10. That is the square root of 169 into square root of 10. So the side is 130. Okay. Now we know this is a right angle triangle and we have to find out the length of hypotenuse. So 130 square plus 130 square. Okay. So we can take 130 square as common, then it will be 1 plus 1. So it is 2 times 130 square. Okay, that is diagonals square. So diagonal will be what? 130 root 2. Okay. So further, no paperwork is required. I have just written all this thing just for the sake of clarity. Otherwise, no need to write. Okay, just try to visualize 130 square plus 130 square, that is 2 times 130 square. That means we have to find out the square root to get the length of the hypotenuse. That will be under root 2 1 into 130. I hope you are clear. Now friends, in this case, one side of an equilateral triangle is 30 centimeter. What is its area? See, there are various methods to find out the area of an equilateral triangle. First of all, we can use Heron's formula, that is root 3 by 4 side square, that is the area of an equilateral triangle. So just put the value of the side over here and you'll be getting the answer. Okay. So that is 225 root 3. Other method is, see, this length is 30 centimeter, this complete length is 30 centimeter, and this is an altitude. So this length will be 15 centimeter as it's an equilateral triangle. So the altitude from this vertex to the opposite side will bisect this length. Okay, so this is 15, this is 30. You can find out this length, that is, you can use Pythagoras theorem. So the length of this will be L is equal to, or L square is equal to 900 minus 225. So this way you can calculate, and after calculating the length you can take half base into altitude as the area of an equilateral triangle. Okay, so various methods are there. This is going to be the simplest method, that is root 3 by 4 side square if you are given the side of the equilateral triangle. Okay, just memorize this formula. Okay, we have also discussed the derivation of this formula in our second session. Okay, so now let's take the next question. Now further we have to find out the area of a triangle. Sides are 16, 30 and 34. Friends, further I would request you to recall that 16, 30 and 34. Half of them is 18, 15 and 17. And I'm sorry, 8, 15 and 17. And these are Pythagorean triplets. Okay, that means these these are the lengths of a right angle triangle. Now any multiple of Pythagorean triplet is further a Pythagorean triplet, that is 16, 30 and 34. These three are also Pythagorean triplet. Now if these are Pythagorean triplet, definitely they are the lengths of a right angle triangle. So what is the formula for area of a right angle triangle? That is half base into altitude. So this is base, this is altitude and this is hypotenuse. So we will be requiring these two data only. So half into 16 into 30. Okay. So if you are able to recall that these three are making a right angle triangle, then this problem will be very simple for you. Even you can do it mentally, because what you have to do, you just have to multiply 30 and 16, then you have to divide it by 2. That's it. That is half base into altitude, and the calculation can be done mentally, right? Now in this case, we are given that the perimeter of a triangular field is 144 and the ratio of sides is 3 is to 4 is to 5. The area of the field is. Further, just recall 3, 4, 5 and their multiple or multiple of 3, 4, 5, they will form a Pythagorean triplet. So definitely it is a right angle triangle. Okay, with sides 3x, 4x and 5x, right? Now the perimeter will be what? Like 3x plus 4x plus 5x, that is 12x. Now 12x is 144, that means x is what? 12, right? That means the sides are 12 into 3, 12 into 4 and 12 into 5, isn't it? Okay, now the sides are 36 and 48, that is base into altitude, base and altitude. So the what is the area of a right angle triangle? That is half base into altitude. So it's half. Sides will be 12 into 3, 36, 12 into 4, 48. We don't require this because in the calculation of area of a right angle triangle, hypotenuse is not used. So it's half base into altitude, 36 into 48. Okay. So 18 into 48 is your answer. So that comes to 864 meters square. I'm sure you're getting me. Just recap if you are not clear about the concept. Let's take the next problem. Now let's see this question. If the altitude of an equilateral triangle is root 6 centimeter, its area is. First of all, we have to find out the sides of this equilateral triangle. Since all the three sides are same, we can take this side as x. This altitude's length is given to us as root 6, and definitely this altitude is bisecting this side. So this complete side is x, so that this will be x by 2. Now they are forming a right angle triangle, these three sides. So we can apply Pythagoras theorem. X square is equal to 6 plus x square by 4. Okay, so 3x square by 4 is 6. So x square is 8. Okay, that is side. Now what is the area of an equilateral triangle? That is root 3 by 4 x square, that is root 3 by 4 into 8. So it's 2 root 3. Okay. Now the radius of a circle is 14 meter, then the circumference of a circle is, the formula for the circumference is 2 pi r. So it's 2 into 27 by 2, 22 by 7 into r, that is 14. So it's 22 4s are 88. Okay, very simple. Let's try this question. The difference between circumference and radius of a circle is 37 meter. We have to find out the circumference. So it's 2 pi r minus r is 37. So let's take r as common. It's 2 into 22 by 7 minus 1 is 37. So it's 22 2s are 44. 44 minus 7 is 37. So r into 37 by 7 is 37. So r is 7. Now we have to find out the value of 2 pi r, that is circumference. So that is 2 into 22 by 7 into 7. So it's 44. Okay. Now if the ratio of area of two circles is this, the ratio of their circumference is quite simple. Area radius is there in square, and in circumference the radius in is linear function, right? So it's suppose pi r1 square by pi r2 square is 16 by 25. That means r1 by r2 is 4 by 5, right? So we have to find out 2 pi r1 by 2 pi r2. So that is 4 by 5. Okay, you don't have to go for any sort of paperwork if you are clear that in area radius is in square function and its circumference the radius is in linear function. So you just have to take the square root of this data to get the answer, right? So it's 4 by 5. I hope you are getting me. Now let's try this question. If the radii of two concentric circles are 15 centimeter and 13 centimeter respectively, then the area of the circulating ring in square centimeter will be. I have drawn the diagram over here. Here, this and this. These two are the concentric circle, that is the single center or having the common center. Suppose it is O. Now radius of this small circle is given to us as 15 and the radius of the bigger circle, this is 13 and this is 15 obviously. Okay, so we have to find out the area of this green ring. Okay, that means we have to find out the area of this outer circle, then we have to find out the area of this inner circle, and if we find out the difference between them, we'll be getting the area of this ring. That means area, this is suppose area 1, this is area of the circle is area 2. That means difference between outer area minus inner area will give us the area of this ring. Okay. Now as simple as that, it's pi r1 square minus r2 square. That means area of outer circle minus area of inner circle. So it's pi r2 square minus r1 square. Just put the value. R1 R2 square is 15 square, that is 225, or we can say it's R2 minus R1 into R2 plus R1. So 15 minus 13 into 15 plus 13. Okay, so it's 44 into 4, that is 176. 176 square centimeter is the area of this ring. I hope you are clear. Now let's see this problem. A sector of 120 degree cut out from a circle has an area, thus the radius of the circle is. Now this is center of the circle and this is 120 degree and this is the sector that is being cut out. Okay. Now area of this particular sector is given to us as 9 3 by 7 square centimeter. Now we can see that the complete angle is 360 degree, as the center angle of a circle is 360 degree. That means this is 1/3 of the circle. Okay. So the complete angle theta is 360 degree. That means this angle will be 1/3 of 360. So area of this portion will be 1/3. Okay. So the area of the complete circle will be 3 times this. Okay. So I can say 1/3 of pi r square is this. That is 63 plus 3, 66 by 7. Now we have to find out the radius. So it's 1/3 into 22 by 7 into r square is 66 by 7. So r square is 9, that means r is 3. Okay, as simple as that. You just have to be clear that the area of this sector depends upon the angle. So area of the sector is determined by theta by 360 into pi r square. Here theta, in this particular case, theta is 120 degree. Okay, in this case, theta is 120 degree. I hope you're clear. Now let's try this problem. Friends, we are taking the basic problems of various 2D and 3D shapes. You just try to understand the basic concepts and try to solve them on your own. And in the next session onwards, we'll be taking some difficult ones. Okay. So here the ratio, I'm sorry, this is ratio. The ratio of radii of two cylinder is this, and the heights are in the ratio 2:3. Ratio of their volume is. Okay, what is the volume of a cylinder? That is pi r square h. So it's pi r1 square h upon pi r2 square. It's h1 and it's h2, since h1 and h2 are also different. Okay. Now the ratio of radii is 1 is to root 3. So we have to write down the square of that, since it is r1 square by r2 square, or we can say it's r1 by r2 whole square. Pi and pi will get cancelled. So r1 by r2 square will be 1 upon 3 into h1 by h2 is 2 by 3. So the ratio of volume is 2 by 9. Okay. Now friends, we have an interesting problem, and I would suggest you try this problem on your own and then match your solution and answer with mine. And I would suggest you once again that do not touch your paper and pen, just try to solve it without anything, and maybe mentally. Okay. Instead of walking along two adjacent sides of a rectangular field, a boy took a shortcut along the diagonal and saved a distance equal to half the longer side. Then the ratio of shorter side to the longer side is. Okay. See, there is no paperwork required at all. Just a basic analysis is required. So these are the adjacent sides, and the person, if he has to reach from this place to this place, he had two choices. Either he goes this way or he goes this way. So what is told in the question, that is he is taking this way, that is he's getting along the diagonals, he's walking along the diagonal. Okay, now while walking along the diagonal, he's saving a distance equal to half the longer side. That means whatever is this length of this side, suppose it is x, that means this banda is saving x by 2. Maybe meter or maybe kilometer, whatever, right? Now we have to find out the ratio of this distance and this distance. Now the very simple and obvious thing over here is this is this is a right angle triangle. Okay, and these two adjacent sides are forming perpendicular and base of a triangle. Okay, now first of all, from the options, just try to find out in which of the options you are getting a Pythagorean triplet, because options are quite simple. They don't have much irrational numbers in that. Okay, so that means we have to just find out a Pythagorean triplet. So from 1 and 2, there is no Pythagorean triplet. 2 and 3, no. 1 and 4, no. From 3 and 4, yes. 3, 4 and 5, they are making a Pythagorean triplet. Okay. So suppose I assume this to be 3, this to be 4. Okay. So this will be definitely 5. Now, if he is walking along this way, that he might have, he has to walk for 7 units, and if he's walking this way, he has to run only for 5 units. That means he is walking 2 units less, that is half of the longer side. That means all the conditions are matched. Okay, that means 3 by 4 is the correct answer. And how did we do that? That is just by applying some basic analysis. Okay, that is like we chose 5 Pythagorean triplets. Okay, I hope you are clear. Now let's see this question. The edge of a cube is 20 centimeter. How many small cubes of 5 centimeter edge can be formed from this cube? Now friends, if one body is converted to the other, then its volume is not changed. Okay, so we have to use this concept only. In this case, the volume of the bigger cube, and whenever we have to find out the number So number is volume of bigger body by volume of smaller body. Since its unit is cubic and its unit is also cubic, so cubic divided by cubic, you will be getting a pure number. Okay, so in this case, this bigger cube is converted into this smaller cube, right? So we have to find out the number of smaller cubes. So what is the volume of the bigger cube? That is 20 into 20 into 20. What is the volume of the smaller cube? That is 5 into 5 into 5. So we will be getting 4 into 4 into 4, that is 64 smaller cubes if this bigger cube is converted to the smaller cube. Okay, it's quite simple. Just keep this funda in mind. Friends, I hope you might have enjoyed the session and you might have learned the basics of 2D and 3D shapes. We'll be taking more problems and more difficult ones in the next session. Do revise this session and the previous 3 sessions of mensuration. Bye-bye.